Until now, we've been working primarily with fractions that are less than one whole. Today, we're going to think more about fractions that are equal to one whole or greater than one whole. Let's take a look at the problem of the day. How did you represent this situation with a picture? Say your answers out loud. I heard you say that you drew two circles to represent the two oranges that Lael had for lunch. You said that you partitioned the oranges into fourths because in the problem it tells us that she cut each of her oranges into fourths. What did you do next? Say your answer out loud. I heard you say that you shaded 4 orange slices because in the story it says that she ate 4 of them. What is the unit fraction for this shape? Remember, a unit fraction is 1 part out of all the total parts. That's right, the unit fraction is 1/4 because there are 4 total parts in this whole, and the unit fraction refers to just one of them. Identifying the unit fraction will always help us identify other fractions in the shape. Part A says, if each orange is one whole, represent the amount of orange slices needed as a fraction. What fraction represents the amount that Lael ate? Say your answer out loud. How do you know? I noticed that a lot of you had the correct numerator of 4, but struggled to find the correct denominator. Many of you said that Lael ate this amount, 4/8. Let's think about our definitions. What does it mean if we have 8 as our denominator? Say your answer out loud. I heard you say that 8 as the denominator would mean that we have 8 total parts in one whole. Look at one of our wholes in the model. Do you agree or disagree that the denominator is 8? Say your answer out loud. That's right. I heard you say that you disagree that the denominator is 8 because in each whole there are only 1, 2, 3, 4 equal parts, not 8. If you were a scholar that came up with 4/8 for the amount that Lael ate, what mistake did you make? Say your answer out loud. I heard you say that if you came up with 4/8, you added all of the parts in both wholes to get the denominator. Remember, the denominator is just the total number of parts in one whole. Thanks for having a growth mindset there and being open to making mistakes on a new problem. Let's take a look at the orange again. What fraction represents the amount eaten of these 2 oranges? Say your answer out loud. That's right. Lael ate 4/4 of her oranges. What do you notice about this fraction? I heard you say that you notice that for this fraction, the numerator and the denominator are the same number. Use your definition of numerator and denominator to help you explain what it means when these 2 numbers are the same. Take a risk, share your answer out loud. I heard you say that when the numerator and the denominator are the same, this means we're describing or referring to the same number of parts that are in one whole. So, we're talking about all the parts in one whole. There are 4 parts eaten out of 4 total parts. Nice work. When the numerator and the denominator are the same, the fraction is always equal to one whole because we're describing all the parts in one whole. We can think, is my numerator and denominator the same, to help us identify fractions that are equal to one whole. Let's take a look at part B. What fraction of the oranges were eaten now? How can we represent that? I heard you say that we should shade 2 more pieces to represent the amount that Lael's friend ate, and that we can describe the amount eaten now as 6/4. How do you know? Why is the denominator 4? Say your answer out loud. That's right. The denominator is 4 because the denominator means the total number of parts in one whole. And we still have wholes that are partitioned into 1, 2, 3, 4 equal parts. Why is the numerator 6? Say your answer out loud. Yes, that's right. The numerator is 6 because there are 1, 2, 3, 4, 5, 6 slices eaten. Those are the parts that we're referring to. Let's count by the unit fraction to check. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. What do you notice about this fraction? I heard you say that the numerator is greater than the denominator. Using your definitions of numerator and denominator, describe what it means when the numerator is greater than the denominator. Take a risk and share your answers out loud. I heard you say that this means we're talking about more parts than the parts that are in just one whole, so there must be more than one whole. That's right. When the numerator is greater than the denominator, the fraction is greater than one whole because we're describing more parts than the number of parts in one whole. We can think, how many parts are in one whole, and am I describing more parts than that, to help us identify fractions that are greater than one whole. Keep this in mind as you move into the try one more.